A real-world use of simultaneous equations. Let's consider a real-world example. Your car gets 30 miles per gallon, and your friend, who lives 800 miles away, has a car that gets 40 miles per gallon. You decide to meet for a reunion, but you don't know if your cars will make it to the midpoint with full tanks of gas. So, your problem is how much gas do you need to put in each car so that you two can meet. All you know is that your car can hold 2 times the amount of gas as your friend's car. We have 2 variables quantities in this problem, the number of tankfuls of gas for car A and the number of tankfuls of gas for car B. Let's assign X equals the number of tankfuls of gas needed for your car, car A, and Y equals the number of tankfuls of gas for your friend's car, car B. So, our 2 equations are and. There are 2 ways of solving for these 2 variables, substitution and elimination. Using substitution. To use substitution, just plug in the y equivalent of x into the other equation, does not matter which equation you use first. You could use x equals 2y from equation 2. Or x equals 800 minus 40y all over 30 from equation 1. But it is easier to use x equals 2y. Doing this substitution, we get, which works out to giving the value of y. And since x equals 2y from equation 2, we get the value of x. Your car needs 16 full tanks of gas and your friend's car needs 8 tanks. Using elimination. If we want to solve by elimination, we have to make the coefficients, which are the numbers before the variable, of one of the variables in both equations the same so that we can add or subtract the like terms in both equations to eliminate one variable. Sounds confusing, right? It is not complicated at all, as you will see. First, we rearrange equation 2 to the following equation. And write equation 1 again. Multiply equation 2 by 20 to make the y coefficients the same. Now add or subtract equation 2 from 1, basically subtracting like terms in the equations. If the term in the second equation is already a negative, then add the equations, otherwise subtract. Here we need to add, because the y term in the second equation is already negative. So we get, which gives us, and since x equals 2y from equation 2, we get. So, whichever way you solve, you get the same answer. But remember, you have to have the same number of equations as unknowns. And these equations are called simultaneous equations as they are all true for the involved variables.